If derivatives are not fractions, how come this is a legitimate equation? So what is really not right? Derivatives are indeed fractions, or this equation is just wrong. If you think there is really a contradiction here, chances are either you can't recognize mathematical objects correctly, or you are just reading math without any context. The truth is, there isn't any contradiction at all. I'll clear up your confusion over all these in just a minute. Before getting to what makes this a legitimate equation, let's see how things can go wrong in two different ways. Scenario 1. You read the equality from the right to the left. You also see three unique objects on the right. You then try to simplify things by canceling out the dv's, so you get dp over dt. And perhaps then you recognize, oh, combining the two pieces, this is the derivative of p with respect to t. This analysis is wrong because you treated derivatives like fractions. But what's more dangerous is you believe the equation is okay for the wrong reason. The message you get out of it is that you can simplify the product of two derivatives on the right to get a single derivative. This interpretation is also wrong. Now let's move on to scenario 2. You start reading from the left and see the derivative of p with respect to t. So you try to figure out why it equals the right-hand side. Having the goal of getting two derivatives out of one, you multiply the left-hand side by dv over dv, which is 1, and you think that wouldn't change the derivative. Just an algebraic trick that you've played many times. Then you swap the dt and dv at the bottom. Ta-da, it works. Well, not really. The first move is bad. Not completely wrong, but the intent was just not right. The second move is absolutely alarming. That's wrong because you all of a sudden treated derivatives like fractions, but very likely you still get the right message out of it. The three derivatives are related as such because all you did is try to rationalize it. Like the first scenario, you're in danger because you get the right interpretation but based on wrong arguments. Now let's see a reasonable way to claim that this equation is legit. Here I see three derivatives, and I want to figure out if they relate in such a way. I first look into the first derivative on the right. Now let's say p can be expressed explicitly as a function g of v, so the first derivative on the right makes sense. So what about the one next to it? If v is a function h of t, then the second derivative on the right also makes sense. Now on the left, the derivative dp dt suggests that p depends on t. But did I just assume p is a function of v? Well, that makes sense too, because p depends on t via v. So mathematically, p equals to some function f of t, which is a composite of g with h. So far, so good. The only question remains is why the three derivatives relate in such a way. Well, given p is a composite, if I try to differentiate p with respect to t, I see that the equation comes from applying the good old chain rule, just without formally labeling the outer and inner functions of the composite as g and h. So I say, the equation is legit in such a particular context. Now, after all these walkthroughs, I hope my message is clear. I repeat it anyway. Listen, you cannot treat derivatives like fractions. They're not. The symbol used to represent one of the derivatives in our example is the following one big thing, dp dt, along with the division-like horizontal bar in between them. Yes, the whole thing. You can't kind of like ungroup its components to get dp and dt as two standalone objects by throwing away the lonely horizontal bar just because you're tempted to do so. Besides, think about it. What do dp and dt represent? Well, by themselves, they can be used to denote the mathematical objects called differentials. In multivariable calculus, you'll see they play an important role in the development of the subject. You'll also learn that we can perform certain operations on them, and there are rules you have to obey. For now, the most important point is you were juggling three derivatives in the first place, and you can't cancel two dv's that come from two of the derivatives, as in the way I showed you in scenario 1. All right, I hope you enjoyed the video, and my mission is accomplished. Thanks for watching, and I will see you in the next one.